So, let us continue our discussion about the various payment design methods that we are really looking at. Again, to emphasize, almost all of them will follow more or less the same thing. How do you characterize the material? The material characterization will be different for bituminous mixtures, it will be different for granular material. So, you will be talking in terms of some moduli. So, it could be resilient modulus, dynamic modulus, etc. Same thing here for granular material. Then what is the failure criteria? You can say very generally rutting of the full pavement system, fatigue of the full pavement system, or you can talk in terms of rutting of the granular layer alone or fatigue of the bituminous mixture alone. So, this is the failure thing. Reliability. Now, you can talk in terms of specifics for reliability, reliability for each layer, reliability for the whole pavement system. It all depends on how much of data that we have processed in writing this pavement design code. Then comes the traffic. You can take straight away everything in terms of 80 kilonewton standard axle load. Then you can use the vehicle damage factor approach that we follow in IRC, or you can talk in terms of truck factors with the different growth factors and different axle load distributions. So, there are enough variations that you can look into it. So, the South African method will score in terms of having a detailed procedures for each and every one of these steps. The Australia will be different in it, and my idea is, especially for the students here, is to make you understand how the same pavement cross section is designed by different countries in a completely different method, but all of them will say that they are mechanistic empirical. And we know what is the mechanistic part, we also know what is the empirical part. Now, let us talk about the Australian pavement design code. Now, this is Austroads has lot of very useful wealth of information, and all you really need to do is to just go create a username and password. Most of the manuals, 90% of the pavement related manuals can be downloaded for free. In fact, what you see here is the guide to pavement technology is an excellent manual for you to really read and understand how a pavement should be designed. So, you just need only a username and password, create it, download it, you will be able to read it. And here what I am going to do is, I am going to take this particular approach and show you a brief outline, and in fact you can actually teach around 8 to 10 hours only specifically using the Austroads, but I am not going to do that. Only the idea is to just give you a brief overview. Now, this is the design procedure for the flexible pavement that they have given here. So, the each chapter number is also mentioned here. Now, this is very interesting if you really go through the chapter number. First, if you look at chapter 3, they talk about construction and maintenance influences. So, the starting point is not stress analysis, okay. The starting point is not material characterization, the starting point is from the construction and maintenance influences. The next comes the environment, and see this, the reliability is something that comes in chapter 2, and this is where you basically start talking about what is the expected reliability for any pavement construction. Now, if you go back and look at IRC 37 or in the Huang textbook that we more or less followed, reliability comes lot more later. It first starts with the stress analysis. So, the different countries have a different approach. Now, including the construction and maintenance influences environment, you are talking about subgrade evaluation, you are talking about pavement materials. Then comes a very important chapter, which is what I am going to cover in today's lecture, which is on traffic. So, from the input of the subgrade and the material that you are going to use, you will take a trial pavement cross section, and this is the analysis part. The pavement analysis is the mechanistic part, compute the stresses and strain and use the performance criteria and compare the designs and implement the design. So, this is the overall design procedure that is followed in Australia. So, now what we are going to do now is to talk about the traffic, and similar to what I have mentioned earlier, the pavement design guidelines, pavement design code should always integrate the actual traffic for which it is being designed. Okay. So, what we have in India is the IRC 3 is standing outside of IRC 37, it should be integrated part of it. So, to just give you an idea, I have shown you the traffic, how it is handled in the Australian method. Now, focus your attention on first this portion. So, these are the various types of axles that are being considered: single axle with single tire, single axle with dual tire, tandem axle with single tire, tandem axle with dual tire, tridem axle with dual tire, quad axle with dual tire. These are all the things, and in fact, they have a class starting from 1 all the way going up to 12, but what I did is to just pick class 10, class 11 as well as class 12. Now, if you just take a look at the groups, and these groups are going to be very important to you as we go along. So, how many groups of axles are there? 1, 2, 3, 4. So, this is class 10. So, this could be a tridem, 2 tridems, 1 tandem and 1 single. Similarly, if you look at class 11, it could be either 5 or 6. So, this is 1, 2, 3, 4, 5, it could also be 6, but look at 12, which is what is really called as the triple road train. So, this is 1, 2, 3, 4, 5, it can have 6 and then 7. So, these many groups could be there, and the number of axles are going to be appropriately the same as the groups that you are looking at. Now, depending on the type of design that you are really looking at, you can actually talk in terms of combinations, or you can talk in terms of the axles and the groups here. So, this is the length, this is the axle and group, and this is the vehicle type. So, these are the 3 levels under which the traffic is classified. Okay. So, please keep this in mind. This is the kind of detail that we really need. Now, these are the steps I have summarized after having read through it many times and after having taught from it, and in fact, they have a wonderful software called Circly. There is a student version that is available. You can use it for a trial period, 1 month or something. Try to download it and start using it. Okay. The first thing is, what is your design period? Do we ask this question in IRC 37? Yes. What is your design lane? Yes, we ask the same thing. What is the average daily number of heavy vehicles in the design lane? Slowly we start deviating, and the details that are required as part of Australian design method becomes lot more comprehensive as you go along. So, what is the average daily number of heavy vehicles in the design lane? Okay. Average daily number of heavy vehicles. Then what is the traffic growth in the design period. Okay. Now, this is tricky and they actually account for it if you have the traffic growth more than what you expected after you have constructed, if it happens within the first 3 years or 5 years. So, different traffic growths are also accounted for. I suggest that you go through this whole thing. What is the average number of axle groups per heavy vehicle? Now, what is this axle groups that you are really looking at? This is the axle group that I mentioned here. So, these are the axle groups that we have mentioned here, and what is the cumulative heavy vehicle axle groups over the design period. So, now let us go back and look at it again. So, if this is one axle group, so let us say triaxle or let us say tandem with dual tires. So, there is a tandem with a dual tire here, there is also a tandem with a dual tire, tandem with a dual tire. So, let us say you have some 100 vehicles of class 10 and another 100 vehicles of class 11, and if you take all these axles separately and their load distributions and adjust them, this is what you are going to get. So, what you really need to do is what is the cumulative heavy vehicle groups, axle groups over the design period, and what is the proportion of the axle group types and the distribution of the axle group loads. So, when you collect your axle load data, what is the actual proportion in the total axle groups, okay, what is the proportion of single axle, tandem axle, dual axle and all those things, and what is the cumulative traffic loading. So, we will try to address each of this as we go along. Okay. Now, what I did is I have also given some information related to the various sections from which you can find this information that we are discussing, so that it will become easy for you to use these slides, listen to this lecture and also take a look at the manual that is available to you. Okay, the design period, first question is 20 to 40 years. Okay. Now, understand the difference between design period, analysis period and performance period. Okay, right. What is the design lane? And in fact, there is an extensive day to day data collection, 24/7 data collection that is carried out by Australia using what is really called as the weigh in motion sensors. Okay. And you are expected to collect the data using the weigh in motion sensor only. So, based on the data that you collect from the weigh in motion sensor, you will find out what is the design lane. Okay. Now, a question that I would like to ask the students here is, what do you think is the design lane in a national highway in India as per the current practice, and what actually practically happening? What exactly is the design lane? You will say that, okay, so I have this national highway, so let us say 2 lane. So, this is northbound direction, this is southbound direction. So, you expect a design lane to carry the maximum heavy axle group loading. So, you will basically say that, yeah, I really think this should be the one, but what really will happen if you go in the highway, drive along the highway and see, most of your trucks will not be driving on the outer lane, rather they will be driving on the inner lane. So, this is what you can say not a desirable driving practice. So, that means as the country is growing, as we are constructing more and more roads, there is also some amount of driver education that is needed on how to drive in a rural road, okay, national highway or expressway. The slow moving vehicles always move to the outer lane and then they keep driving at a constant speed. So, that is the typical practice that you will see in most of the countries. So, we will learn as we go along. So, this is our lane distribution factor that you are really looking at. So, if you are talking in terms of a 2 lane, you can actually see that the left lane, okay, that is taken as the design lane, and if you are talking about a 3 lane, again This is what you are really looking at. So, now immediately you will realize what is the numbers ideally we are looking at. Now, what is the next thing that we need to do? What is the heavy vehicle axle group? Okay, so that is what we really need to understand. Okay. Now, this is something that we need to do it for the first year estimate, that is what we need to do, we need to use the WIM data. Now, what is AADT? AADT is annual average daily truck. In fact, if you are using the Astro, you will be talking in terms of annual average daily truck traffic and not the daily traffic, but of course, since we are using the percentage of heavy vehicle, so AADT times the percentage of heavy vehicle gives you your AADTT. Okay. And as I mentioned, I have given this appropriate section numbers here, so that you can actually go and read it. So, this is the initial daily heavy vehicles in the design lane. So, heavy vehicle design lane. So, watch out for I, okay, right. So, this is your average daily truck factor, truck traffic, annual average daily traffic. This is the direction factor, because ideally you will be talking into collecting this full data. So, you will be trying to find out how much is the proportion in the northbound direction, southbound direction, or eastbound or westbound. And similarly, this is your lane distribution factor, and this is the percentage of the heavy vehicle. Okay. So far so good, we have seen these kind of things. So, it is no problem. So, what exactly this is? This is your cumulative growth factor, we know what exactly it is. So, this is the formula that is used. So, let us say if you are looking at a design period of 10 years, and if you are really looking at let us say 6%, this is the factor that you are going to get. So, 365 times Ni times Cgf. So, this is what you are going to get as the design heavy vehicle. Now, there are interesting things. One is, if it is going to be a reconstruction, things are going to be different. If it is going to be a overlay, it is going to be different, and if it is a greenfield project, it is going to be different. And this is where Australian traffic analysis start taking a deviation similar to from what we have seen in IRC. Okay. Now, they start looking at below capacity, near capacity, and above capacity. Okay. So, let us understand what these things really means. Now, the question that you want to really ask is, what will happen if the estimate exceeds the capacity? Okay, it can happen. Now, we need to understand how capacity is defined in traffic engineering. In capacity is defined in traffic engineering as saturation flow in peak hour, because you are basically looking only in terms of how this facility that you have constructed is able to service the traffic that is going on it with the least congestion, least delay. That is the whole idea as far as traffic engineering is concerned. But when we are really talking about pavement engineering, we are talking in terms of the saturation flow for the full 24-hour period. So, that means you want really the truck to be moving one after the other in the 24-hour period. Okay. So, that is the traffic growth now. So, now if you are really looking at the traffic growth pattern, there is a passenger car per hour per lane. These are all the capacity flow rates that are given here. So, if you are talking in terms of through lanes, they are talking in terms of 2300 cars per hour per lane. Of course, this is passenger car, and if it is a multi-lane road and if the posted speed is let us say 100 km per hour, one is looking at 2200 passenger cars per hour per lane. Now, the interesting thing that you are going to use is the average passenger car equivalent. What is given here is something similar to our passenger car unit that we are familiar with. Now, as far as the Astro vehicle classes 10 or 11 is concerned, this passenger car equivalent factor for the heavy vehicle is of the order of 4. Okay. So, now you need to understand really how we are linking the saturation flow capacity with our traffic growth pattern that we are really looking at. So, it is going to be something like 4 or 5. Okay. So, now how do we use this information? Okay. This formula basically tells you how to compute the maximum daily volume of vehicles traveling in the direction of the design lane. So, this is what we want to really compute. So, this is multiplication symbol. So, 24 times CPC is your maximum hourly passenger car per lane, and this is the total number of lane. So, now this is the factor, the passenger car unit kind of a factor that you are using, and this is the percentage of the heavy vehicle. So, what is that you have computed? You are basically trying to compute the maximum daily volume of the vehicles that are traveling in the direction of the design lane. Now, the next step that we are going to do is to compute using this information maximum annual volume of heavy vehicles in the design lane. So, this is the one that we really want. So, that is going to be percentage of average percentage of the heavy vehicle in the direction of the design lane times the lane distribution factor that we are looking at times 365, okay, and times the maximum daily volume of vehicle traveling in the direction of the design lane. So, this is vehicles per day times 365 times lane distribution factor times the heavy vehicle percentage. So, this gives you the maximum annual volume of heavy vehicle in the design lane. Okay. So, what exactly is happening here? In fact, many a times, because I just need to take a small slight detour here and explain you. Many a time you sit down and do the axial load computations, and most of the time these axial load computations that you do are based on the axial load, but where are these axials coming from? These axials are coming from the volume count that you basically do. Now, what is the connection between the actual load carrying capacity or the geometric capacity of the road and the computations that you are really doing? So, these two things have to be related. So, how do we relate this? So, let us now go back in this step. So, what is that you really want? You really want the maximum annual volume of heavy vehicle in the design lane. Okay. So, that means it is the percentage of the heavy vehicles that you are going to in the design lane, and then you are going to multiply it with the maximum daily volume of the vehicles that are traveling in the direction of the design lane. Now, how do we compute this CVEH? CVEH is based on the maximum hourly volume of the passenger cars per lane. So, you know that this is the typical data that is given here, 2300 is what you can actually do here. Now, if you take this 2300 and then use your heavy vehicle factor, you might actually come back and say, you know what, this axial load computations that I have made based on some growth factor that I have assumed might result in a flow condition which will be more than the capacity of what the road can take. Okay. So, when we do our axial load computations, this particular aspect is not really emphasized, and this is where we are emphasizing it here as far as the Astro is concerned. So, some graphs are given here. So, what you see is maximum annual number of heavy vehicles in the design lane, percentage of the heavy vehicles. So, you can see lane 3 and then lane distribution factor is this much. So, this is your cumulative percentage of the vehicles that you are really getting. So, CPC corresponds to this value, the capacity flow rate that we are really looking at, right. So, it could be 2200, 1700, 2300. So, using this you can actually compute what is the heavy vehicle in the design lane for the corresponding year. Okay. So, now what we now need to do is to compute the cumulative heavy vehicle axle group in the design lane over the design period. So, how do we compute that? Cumulative number of heavy vehicles times the average number of the axle groups per vehicle. Okay. So, now we have found out NHV, right. Now, this NHV has to be computed into, you have to use NHV to compute your axle groups, okay. And this we computed using this. What you should always do, you should have data, you should collect the data. If you do not have the data, you could use something like 2.8 or 2.5 that they are basically talking about. So, these are the axle groups, average axle groups that we are looking at it. So, please understand this is the what you can say the average number of axle groups per heavy vehicle. Okay. Now, comes the next part, what is the traffic load distribution. So, what you are going to do, you take the proportion of all axle groups that are a particular axle group type. Okay. So, let us say you have tridem separately, you have tandem separately, you have a single axle, single tire or single axle dual tire. So, these are all the proportions for each of this, and for each axle group you need to construct your statistical distribution. So, the proportion of the axle that are applied at each load magnitude. So, I will show you one sample data and then it will become very clear to you now. So, for Australian MEPDG, now this is very interesting. You will consider the design traffic in terms of equivalent standard axle load for rutting and what they call as loss of surface shape. Okay. So, this is done only for the rutting and this is done for fatigue. So, that means the heavy vehicles and their associated reputations are actually considered the traffic load distributions for fatigue, but for computing the rutting related thing you use the load equivalency factor. Okay. So, now I think it should be very clear how we are deviating. So, how do you do the ESA calculation? It is the same thing. So, what is this ESA? ESA IG, number of reputations of a standard axle, which will cause the same amount of damage of a single passage group of type I. Okay. So, it could be a single axle with a dual tire, tandem axle with a dual tire, etc., with the load L I comma j. Okay. So, what is this j? J is the load magnitude and I is your load group. Okay. I think it is very clear now. So, what is that you are using? You are using your fourth power and this is the value that you are going to use here. So, whether it is going to be 80, whether it is going to be 135, 182 and 226. Now, can you go back to IRC 37 and compare the values that are shown there with the values that are seen here, okay, right. So, what do we now do for the fatigue? So, there is a interesting equation, distress equation that is given here. So, this is your reliability factor. What you see here is the okay. So, this is your volume of binder, this is the micro strain and this is your modulus value, and these are your calibration factors. Okay. So, this is the equation that you are going to use for the fatigue calculation, right. So, they also give you some kind of an upper limit for the fatigue. Now, why as the temperature increases, the fatigue design traffic loading limit, what is really called as the DISA, is reduced, is something that we can discuss only in an advanced course. So, there is something to do with stress relaxation, healing and all those things that can happen, and some of them happen at different temperatures, and at high temperature what can happen, there could be an accumulated permanent deformation, and there is also a lot of interesting issues related to creep and fatigue interaction. We will not get into all those details, because immediately you should be thinking, okay, why is this temperature greater than 35 degrees centigrade, and why is this teacher talking about traffic loading limit at 35 degrees centigrade and above, at 35 degrees centigrade and above, will we really have fatigue? Yes, you will have fatigue, but that is a story for different time, not now. So, what exactly is this NDT limit? Is the cumulative number of heavy axle groups over the design period. So, this is the ESA HVAG is the heavy vehicle axle group, is the average number of equivalent axles per heavy axle group. So, this is what it is. Now, there are some sample calculations that are shown here. You can actually see 20 years is the design period, AADT is 5350, direction factor is given, percentage of heavy vehicle is given, lane distribution factor is given, 4% is the growth rate factor, and this is the traffic load distribution. In fact, this is what you are really talking about, SADT, TAST, TADT, TRDT, and the axle load group is given here. Okay. So, what I would request all of you is to go to this particular appendix, try and see whether you can do the calculations. Okay. So, in the next lecture what we will do is to talk about materials. Thank you.